All right, hello guys. This is Joshua. You can just call me Josh. And I just made a tutorial. It's a simple prediction market. It can deploy it on any chain, but I chose Kaia, so I'll be deploying on. I can deploy on Kaia. So then Kaia is the native token for that chain. And I've already built it. The link to the GitHub repo will be down below in the description. So it's simple. We are yet to build out the front end. So I just worked with the smart contract. So I'll just put you through that. And these are already been deployed. As you can see, the cache is here and the broadcast from before. So I'll be using Foundry. It's simple. Let's open up our terminal. We draw this up a little bit, and okay, no mind this Python error. So what we'll just do is, let's say we are creating a new, for the beginners here, a new Foundry project. We'll just do forge init blockchain. Sometimes we have to add no commit, no commit, no. So click on that, but I won't because obviously I've created that. So what I'll just do is to go into my um, blockchain folder here. So it's simple here. We go to the SRC folder. So I have three smart contracts here. The first smart contract which we'll be working with is the prediction market smart contract. As you can see, the title of the smart contract is prediction market, and this is basically like a binary outcome. And what that means is we can, when you create a market, it can only have two answers, yes or no. We could make the code more robust, having seven answers, but for the purpose of this tutorial I just stuck with a binary answer. Plus we'll also see why. Then we also utilize human optimistic oracle. Human optimistic oracle is deployed on a number of chains, but I stuck with Sepolia. So you need a Sepolia testnet. You can get that from Alchemy, Chainlink, and I think if you are too. So here we just did our basic custom errors. And we'll get to see them later on in the code. These are state variables, the owner here, and then the oracle relayer. We'll get to see, okay, this oracle relayer, how this architecture of this DApp is such that it's cross chain. Just like I said, if you could deduce it, this smart contract will be deployed on Kaia, but our oracle is on Ethereum. So that means we'll need, let's say, like I call it Oracle Relayer. So we need a mechanism such that both blockchain can talk to each other, quote and unquote. And so that's this Oracle Relayer will be the address of the Oracle Relayer. The Oracle Relayer will be deployed on Kaia or whatever blockchain we want to deploy it on actually. So obviously, as with all markets, we will need to have a deadline for it, and that's this the state variable for that. Then when they will need to know whether the market is resolved or not yet resolved. Then obviously the outcome. So we've just created mappings for the amount of Kaya each user will bet, yes or no. Then the total bet, that's for each market. The total bet on yes, total bet on no. So if you win, you get to claim the winnings. If not, it's market, a prediction market. So also we have events, and we'll see where the events will be emitted. Also, you have the oracle data and the when the market will resolve, you get to see how we use them. So we see these modifiers. For this only owner, we could also use Open Zeppelin. let's say if we are to deploy on, let's say, Ethereum or whatever contract, we could just use Open Zeppelin um, enable token, so such that we just get to call um, down the contract on the owner. So we'll go back up. Let's put this down. Okay, so we continue. We get only layer these modifiers. We get to see how we use them later on. Then we obviously have our constructor. Um, our constructor taking two parameters. That's our betting duration and our layer address. So betting duration is how long. Let's say something as simple as who will win the EPL Premier League. So we can put that for a space of a year, and then at the end of the season, we come back. Same thing with NBA League. At the end of the season, we come back. So it takes in three state variables. That's the message of sender, whoever is going to deploy this address. So we also put in the block timestamp deadline. That's the deadline of the block timestamp, which obviously a reserved keyword, then the betting duration, then the oracle layer address. That's this parameter here. Okay, so we have, I think, 4 or 5 functions. 1, 2, 3, 4, 5. Okay, six. So let's quickly go through them. We have obviously our bet yes function. So that means if, let's say, we have binary, it's a binary contract, so that means we can only bet yes or no. So if Arsenal win the Champions League, left to me is an obvious no, but for benefit of the doubt, let's say someone bets yes. So we have a custom error here, and the reason I chose this over the normal require error was because this saves gas. So make sure that the person stake more than 0. So your Kaia must be more than 0, and this bet amount that's this. So okay, let's do this at the first. So I'm just using Alt up, that's the shortcut. Then we have bet no, still same format. So just add this is I'll bet or no the messages, then we increment this value, also increment the total bet or no. So we'll have this function. Okay, so this function will request the market data. So let's see, read this. So it requests data from the oracle by emitting an event. So this function will emit an event that's when we've created the market. So it emits the question that is to be resolved by the oracle. That's our human oracle here. Then it's only callable by the owner of the contract. So after the betting deadline too. So we'll also have after the betting deadline, just to make sure that someone doesn't end someone doesn't, how will I explain it now? Let's say you have you've created a market. The deadline which you put in here must have elapsed. So we have the next function here, which is resolve markets. So the resolve market deadline is resolve market based on the outcome provided by the oracle. So that means and this is by the relayer oracle, it can only be called by the relayer. So what happens is once we've emitted the event to the oracle resolves it. So that means if the answer is yes or a no, then we will get our message back from the oracle, then it emits market resolved. So we have claiming winnings. Obviously, this is how you get paid. So you must make sure that the market must not be resolved first. So we must make sure that we've not claimed the winnings before, so we can't claim winnings twice. So um, here I choose to use the require here actually, just to make sure I don't use too much loops, too much. There's no excess looping here. Then uh, get paid, so use paid keyword here. Then it's as simple as that. We can also withdraw unclaimed funds. So we say it allows owners to withdraw unclaimed funds after the market is resolved. So ensures that the market outcome has been resolved before withdrawing funds. So that means after, let's say, we've settled winning, if you've not claimed your fund and call this contract, and it's only callable by the person who uh, who deployed this contract.